to determine linear, we need to know, do any terms contain products or functions of y? In the A part, we're looking at this term, and this term. And this term doesn't contain any y's at all. This term has the function y, but the rest of the product is functions of x, which is okay. This is the derivative, and the rest of the term is functions of x. So this one is linear. The second one, it's real quick to notice that y squared means it's not linear. And the third one, we have the derivative of y. We have y. There's no y's at all in that. This one is also linear, since there are no products of y's. Here's the derivative of y. No y's, linear. Here's a y to the third power, not linear. Now for part A, to write that in standard form, we need to divide through by the x squared so that the coefficient of the dy dx is just a 1. So if we divide through by x squared, we'll have dy dx. We'll have 3y and sine of x over x squared. On the C part, that's not linear, so we don't need to write it in standard form. On the E part, to write it in standard form, we're going to take the two terms, xy plus 3y, factor out the y, and then move that to the other side. So we would have a dy dx minus an x plus 3y equals 1. On the G part, it's already in standard form, so we don't need to do anything. And the E part, the I part, is not linear, so we don't need to write that. Now I will work on the E choice for you. To put this in standard form, we need the 10x squared over on the other side. We also need the coefficient of dy dx to be a 1. So when we move the 10x squared over, we would have and when we divide through by x, we would have this. And so here is what we are calling P in the standard formula. And our integrating factor then, which we call by the Greek letter mu, is e to the integral of p dx, where p is 3 over x. So here, the integral of 3 over x comes out to be a 3 ln x. We don't need the plus c. And so our integrating factor would be e to the 3 ln x. Now to use the properties of logarithms on that, we will move the 3 up here in the exponent. That would be e to the ln of x to the 3. And e to the ln of x to the 3 comes out to just be x cubed. So that's our integrating factor. So then we write our original, well, our standard form, not original as in way up there. We write our standard form for the differential equation as a mu x cubed times y equals, and then over here we'll have an integral that has mu times f of x dx. Now we need to integrate that. That's the same as 10x to the 4, and the integral of 10x to the 4 would be 10x to the 5 over 5, or 2x to the 5. So we get x cubed equals 2x to the 5, and our constant of integration we can solve that for y by dividing through by x cubed. So y would be 2x to the 5 divided by x cubed, and c divided by x cubed. Now 2x to the 5 divided by x cubed would just be 2x squared. And we can usually write this, c over x cubed, as just cx to the negative 3. There's our solution. And finally, for the initial value problem, we'll work on the C choice. Now this is already in standard form. We will find our integrating factor by doing e to the integral of p, where p is the 5, so we need the integral of 5 dx, which is obviously 5x. So our integrating factor comes out to be e to the 5x. So we need to rewrite the entire left-hand side as mu, that's e to the 5x, times y, and then the right-hand side would be mu, that's e to the 5x, times the f of x, which is e to the negative 3x. Now e to the negative 5x and e to the negative 3x comes out to be an e to the 2x. We can integrate e to the 2x. That would be e to the 2x divided by 2. And then our constant of integration. And we can find y by dividing through by e to the 5x, which is the same as multiplying through by e to the negative 5x. So we end up with y equals, now this e to the 2x and e to the negative 5x would give an e to the negative 3x, and then that we would just write as c e to the negative 5x. Now our initial condition was that y0 equals 0. So we're going to use a 0 for y, 0 for x, and see what we get for c. Well, this would be a 1/2 e to the 0, which e to the 0 is 1. So that would just be a 1/2 plus c. So c comes out to be a negative 1/2. Therefore, our answer is y equals 1/2 e negative 3x minus 1/2 e negative 5x.